All right, so I wanted to do a little bit more with expected value. And again, expected value is really a weighted mean. So I don't know if you guys have ever, done GPAs by hand or whatever. So, but like if you have, say, I don't know, get my pen to work here. All right, so say like as far as GPAs, say you have a 4 credit A and maybe a 3 credit B, and you're trying to figure out your GPA. It's what we call as a weighted average, right? So it would be a weighted grade, so to speak. So the weight would be the credit hours, and then an A is worth a 4.0, and let's maybe make this a C. Then you'd have a 3 credit 2.0. And then what you do is you take the weight times the value. Oh boy, I'm having issues with this pen here. I might have to give up on this. And so weight times value is 16, and then weight times value is that, which is what, 6. And so you add those together. So you take 4 times that is 16, and then that together you get what, 22. And then you divide it by the total weight, like the 7, to get your weighted average. And so it's kind of like, your GPA is like, what is your average per credit hour? So this person has a 3.14 GPA. That's kind of what expected value is. It's kind of like a weighted average. All right, so let's look at this. And there's 2 ways to do this, so I want to show it both ways. A local symphony decided they're raffling a microwave. Okay, now if you do one chart, then your probability should add up to 100%. So if you have they list out 2,000 tickets, so they print them. So you have a 1 in 2,000, 1 in 2,000, 1 in 2,000, or no, I guess there's 2 books worth 20, so 2 out of 20,000. There's 4 chances to win, right? 2 books, this and this. So that means everything else is your chance to lose, okay? And so these should add up to 100% or 1. Now, in this, if you're going to do your chart like this, then if you spend $1 on the raffle ticket, you have this probability of losing it. And then this is what you net when you win. So you subtract the $1 because you really only win this much, win that much, win that much, all right? So then if you multiply, so again, the formula is probability times value, kind of like a weighted mean. So I'm going to multiply these, and then I'm going to add up. And if you're like, well, why don't you divide? Well, it's 100%. So like that's not, you're out of 1 or a whole, so that's not going to matter. So if you take 399 times 1 over 2,000 plus 79 times 1 over 2,000, oh boy. This pen is just a mess here. 1 out of 2,000. And this guy is plus 19, 1 out of 2,000. Oh, 2 books. And then plus a -1 times 1,996 over 2,000. Okay, so type that in your calculator again. If you don't have a good calculator, use Desmos. All right, so I have 399 over what, 1 over 2,000, and then plus 79, 1 over 2,000, and then plus 19, and that's what, 2 of them out of 2,000, and then a -1 or -1 if you want to do that, and then 1,996 out of 2,000. So if you like to do it this way, these are always going to add up, the probability should add up to 100%. And so I basically, on average, I'm going to lose 74 cents. Kind of like with a GPA, on average, that's the grades I normally get. On average, if I do this this raffle ticket a lot, I'm going to lose that. Now, the other way you can do this one, the raffle ticket ones, is kind of do your losing part and your winning part separately and then combine them. So, and that way, if I focus on, okay, so I have a probability and a value. And so my probability, I just have a 1 in 2,000 chance, 1 in 2,000 chance, and what, a 2 in 2,000 chance. And then I just literally put the value, $400, $80, and $20, okay? And so I just kind of worry about that part, all right? So I have my 1 and my 2,000. Let's see. So let me do the math here. So 400, and then I have 1 over 2,000 plus, what do I I have next? 80, 1 over 2,000, and 2 over 2,000 times, what is that? Value of 20. All right, and I get 26 cents. So again, that's our average what I'm going to win, and that's the full value of what I'm going to win. But then I could, oh, sorry, I wrote that backwards. This is my winnings here. Now, what am I going to lose? Well, again, I'm going to make a separate chart. So I'm not combining these charts. I'm doing them separate. The probability of me paying for a raffle ticket is 100% because I bought it, right? Like, I know I bought a raffle ticket. And I lost, what, $1 on that raffle ticket? Because I for sure bought it. I didn't for sure win, but I for sure bought it. Okay, so this is kind of like, what are your chances of winning money? What is the chances of you losing $1? 100% because I for sure bought it. And then if I do the net, I lose 74 cents on average. So if you think of it separately and combine it, you kind of need to do it this way. If you want it to add up to 100%, then you need to think of, if I win, what do I net? If I win, what do I net? If I win, what do I net? And then if I lose, this is my probability of losing, what do I net? So maybe I shouldn't do lose. Maybe I should be like, say, money spent here or something like that. All right, let's look at the next one. All right, so we have two people playing a game. All right, and basically, you know, if you call heads and the person, you know, gets heads, then they have to buy you a cup of coffee. All right, if you call tails and you lose, you have to basically, you know, buy the other person a cup of coffee. And so these are the four scenarios. It could be you said heads and it really was heads. You said heads and it really was tails, so you lose. Or it was tails and you called tails and it really was heads, so you lose. Or it's tails and you really called tails and so you win. So those are kind of the four possibilities. All right, so here's my probability and value chart. I usually put probability on top, value on bottom, but it really doesn't matter. So this is your probability. This is your value. So what are the four scenarios? Where there's a fourth of a probability that you're going to get it right, or you're going to get wrong, or you're going to get right, or you're going to get wrong. So this is kind of the heads, you win, heads call and you lose because it was really tails. This is you call tails and you win because you were right, or you call tails and you actually lose because you called it wrong. All right, so you have a fourth. If you win, you gain $1.20, it's positive, but if you lose, you have to pay your friend $1, you know, buy their coffee. If you win, it's a positive 120, and if you lose, it's a negative 120. So again, you take probability times value, probability value, you multiply these, and then you add it all up. All right, so again, like a weighted average or weighted mean. So if I do that, you know, let's see, I'm in the sum there. Probability, let's see, $1.20, and this is a fourth. And then it could be a negative $1.20 if I lose, right? And a fourth. And a positive $1.20, and I right, so positive there. And then let's see, I lose $1.20 and a fourth. Okay, so if you type that in your calculator, right, you should get 0. And so if you get 0, that's what we call, what is in math is a fair game, meaning everyone's equally likely to win. All right, so, you know, so those are going to be kind of the same there. So it's what we call fair game. No one has an advantage over the other person. All right, I could give you, let's see, what's the next one? I don't know if I have the scenario. Oh, so here I could give you, like, someone already figured out the data of maybe this is a probability of, oh, let's see, I don't know, maybe people having 5 children, say. So probably 0, and say it's, I don't know, say they're capped, or maybe it's 5, maybe it's adopting 5 pets from the ARL, I don't know, but that would seem like this would be higher probability. Maybe it's children, probability of having this many kids, okay? And I know you can't 6, 7, 8, 9, 10, but just pretend. So again, what is the expected value? You would just take 0 times that, plus 1 times that, plus that, plus that, plus that, plus that, and that would give you what you expect on average. It is going to end up being an average. So you take 0 times this, 1 times this, and I might have cut off the context on this one because I can't remember it. All right. So on average, right, you're going to have about, if you do the math here, 3.9249. Now, if you're going to guess, right, like which of these do you think is the most common? Well, this is going to be rare. That's kind of rare. This is 6%, right? This is 22%. That's 30%, but this is 41%, right? So I'm kind of guessing around 4 would be, you know, the average, right? And maybe not with kids, but whatever the context is. So do you see how, right, like I can kind of guess this is the highest probability. These are pretty low, so it's going to kind of err up here where your higher probability is. So on average, that's what's going to happen, whatever the context is. All right, and then here, a teacher gives a quiz with 8 questions. She records the number of correct answers. What is the expected value? Okay, so let's see. What do we have here? So this is 6 people, right? Everyone see this is 6 out of, and we'll have to figure out the total. This is up here is 10, and this one is what? 12. And over here we have, if we go across 7, so these are both 7. And over here we have what? 4, and this one is also 4, right? Okay, and if we add those all up, right, like how many people is that total? That adds up to 50. So this is out of 50 people, 50 people, 50 people, 50 people, 50 people, 50 people, 50 people. So I could get the probability if I divide this as 12%, 20%. If I just divide this, I get 24%. Or I could get it out of 100 double and get it out of 100. You know, that would work. Double 8 out of 100 is 0.08, 0.08. Or you could write 8%. So again, I added up my totals, the 6, 10, 12. That's how I got the 50. All right, so what's your expected value? Like, what would you expect? So you take the probability times value. So here's your probability. Now, what's the value is they got 2 right. That's the value. So 12% of the people got 2 right. 20% got, what, 3 right. Okay, so just take the probability times the value. And again, the order of these doesn't matter. 24 times 4. What do I have? I have 14% and what? 5 and another 14% get 6, right? So again, I'm just doing those. And then I have probably 8% times the 7 and then the other 8% times 8. So again, right, like most of the people, if I kind of look, you know, this is 3, this is 4, but we're kind of heavy up here, right? Most people didn't get 2 or 3. The majority of them got 4, 5, 6, 7, or 8 right, correct? So if you type this in, what is the expected value? Like, what do I represent? Now, there's no gambling involved, so there's no negative in here. So multiply, 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 and then add up all those. And I got 4.54. So this would be questions correct. So on this quiz, you know, the teacher would represent, this is kind of the average behavior, right, on this quiz, the average student, right? Like if students take this quiz a lot in different sections, you know, on average, they get, you know, about 4.5 of the quiz questions correct. That would be normal behavior. Okay, I want to look at this question in your book, and it talks about from the perspective of an insurance company. There's a 27 out of 10 million chance that someone would die in a plane crash. If so, if you buy the insurance, you know, they would have to pay out $100,000, and that would cost the person $1. Now, they want to find the expected value for the insurance company, not for the person. So if you do it separately, kind of like we talked about with the raffle, their probability is 27 out of 10 million people would die. That means they would lose $100,000 because this is from their perspective. Now, for sure, they're going to gain the $1 because if you didn't take out the policy, you can't get the 100,000. So then those don't matter. It's only the people. So 100% of the people that have this insurance took it out. So that's $1 that they make. Our net, they're netting 73 cents per person. Because will people sometimes die in a plane crash? Yes, very rare. If you don't do 2 separate charts, doing the losing and the money made, then the other way is to do it in one chart. And then these probabilities have to add up to 100%. So the probability that they're going to lose, now again, they're not losing 100,000 because we're doing the $1 in the same chart. So they would lose this much money, but again, only this probability. And then this is a probability that they're going to gain that $1. And so if you take this times this times this, you're going to still get the same answer of 73 cents. It won't matter. All right, hope that helps.